Okay, on these notes, we're going to be verifying trig identities. So you are trying to make one side look exactly like the other side. One side has to stay the same. You typically work on the side that has more things going on, like the one on the left here. We want it to look like this right-hand side. So what we're going to do is all the way down, you'll keep writing sine squared theta on the right-hand side. On the left, you're just going to work it to make it look the way you want it to look. Okay, so in this first one, I need to try to make this look like sine squared theta. Well, what I'm going to do, I've got a fraction here, and your numerator is broken up into technically two terms divided by that one term. I'm going to break this up into two separate fractions, kind of undoing the common denominator thing we normally do. I can't read what that says now, sorry. So on the first fraction, it'll be secant squared theta divided by secant squared theta. And then we're going to do minus 1 over secant squared theta. That splits this fraction up into two separate fractions. Well, secant squared over secant squared is just 1. And then the one, remember our reciprocal identity that says 1 over secant squared is the same thing as cosine squared. So I'm going to replace that with cosine squared theta. And then again, I'm keeping the right-hand side the same all the way down. Okay, then I want you to remember your Pythagorean identity that says cosine squared theta plus sine squared theta equals 1. So I know that when I move this over here, I'll be left with sine squared theta equals 1 minus cosine squared theta. So I can replace this with sine squared theta, which is what I want it to be. So I have verified this identity. All right, let's do another one. Okay, on the next one, I'm going to leave the left-hand side alone. I'm going to work on the right-hand side. I have two fractions. Remember, when you have two fractions, you need to get a common denominator. So we'll keep the left hand. I'm going to just write A for alpha. Keep the left-hand side the same all the way down. When I get a common denominator, I'm going to be multiplying the fraction on the right by 1 minus sine alpha over 1 minus sine alpha. And I'm going to be multiplying the one on the left by 1 plus sine alpha over 1 plus sine alpha. Okay, so when I do that, I'll be left with 1 plus sine alpha over that common denominator. And then plus the other one, 1 minus sine alpha over that common denominator. Okay, now that we have a common denominator, we can combine our numerators. So I'm going to combine all of this by combining like terms, and I get 2 because the signs will cancel. All over, now remember on the bottom, when you multiply that out, that gives me 1 minus sine squared alpha. That's a difference of squares. So that's the same thing as 1 over cosine squared alpha. And then 2 over cosine squared alpha. And then I want you to think about that as being 2 over 1 times 1 over cosine squared alpha, which would just be 2 times secant squared alpha. And, which is what we're trying to get to. I forgot to keep writing my left-hand side all the way down, but I have verified it. That is the same thing. Okay, on this next one, we need to remember our trig identities like tangent squared theta plus 1 equals secant squared theta. Also remember cosine squared theta plus sine squared theta equals 1. So I can replace this first one with secant squared theta. And then I can replace the second one with, technically, when you move the 1 over this way, I would have to move the sine over this way. So that means cosine squared theta minus 1 equals a negative sine squared theta. So I'm going to replace cosine squared beta minus 1 with negative sine squared beta. And I just realized I was using the wrong variable again. Sorry. So that's secant squared beta, and then this one's negative sine squared beta. And we're trying to make it equal what? Negative tangent squared beta. All right, remember secant squared is the same thing as 1 over cosine squared times that negative sine squared over 1. multiply fractions straight across. So when you multiply that out, I forgot to write my right-hand side. That multiplies to be negative sine squared beta over cosine squared beta. And that does equal negative tangent squared beta. And so you have verified it. Okay, on this next one, I'm probably going to work with the left-hand side. I usually like it whenever I'm going from two functions that are being added to something that's being multiplied. So I'm going to work on the left-hand side. So the directions even kind of help us here. There's no, and nothing is squared. There's no ones in something squared, so I'm not going to be able to use a Pythagorean identity. I could technically change this cotangent to be 1 over tangent, and then get a common denominator between those two. But I'm trying to get secant and cosecant, which are reciprocals of sine and cosine. So that's why we want to turn everything into terms of sine and cosine. What you're trying to reach should be your guide to help you figure out kind of what your process should be. Okay, so I'm going to change a tangent using our quotient rule that says it's tangent sine x over cosine x. And then cotangent, which is the reciprocal, is cosine x over sine x. And we're trying to make that be secant x, cosecant x. All right, I need a common denominator. So I'm going to multiply the fraction on the left by sine x over sine x, and the fraction on the right by cosine x over cosine x. So when you do that, you get sine squared x plus cosine squared x all over that common denominator, sine x cosine x. Okay, you should see a Pythagorean identity right there. That's the same thing as the number 1 over that common denominator. I forgot to rewrite my right-hand side, sorry. Okay, now then think of that 1 over sine x cosine x as 1 over sine x times 1 over cosine x. They've just multiplied it together. And then 1 over sine x is the same thing as cosecant x, and 1 over cosine x is the same thing as secant x. And technically, 2 times 3 is the same thing as 3 times 2, so I can just switch that order. And then it looks exactly like the right-hand side. So we have verified it. All right, let's do another one. Okay, on this one, goodness, I'm probably going to work with, I think I'll work with the right-hand side. So we're trying to make it look like secant x plus tangent x. And I'm going to try to multiply the top and bottom by something that would help me. Right now, I can't do anything much with this. I can't break it up into two separate fractions because the top isn't where the minus is. This isn't just one term on the bottom, so we can't break it up. But if I multiply the top and bottom by 1 plus sine x, I'm multiplying it by the number 1. That's the same thing as the number 1, so I'm not changing it. I'm just making it look like I want. But it would help me out with a little bit with the bottom, because that will end up being, when you multiply those together, 1 minus sine squared x, which is the same thing as cosine squared x. So multiply straight across. I've got to remember to distribute my cosine through there. And that'll be cosine x plus cosine x sine x all over cosine squared x. And so then, I guess I should have kept that cosine factored out. So that's cosine x times 1 plus sine x all over cosine squared x. So now we can cancel here. That cosine x goes into one of those. And so now I'm left with 1 plus sine x over cosine x. So now that I've got the plus in the numerator, I can break that up. So that's the same thing as 1 over cosine x plus sine x over cosine x. And then using my reciprocal identity, 1 over cosine x is secant x, and sine x over cosine x is tangent x, which is what we're trying to look like. So we have verified it. Okay, on the next one, I'm going to work with the left-hand side, I believe. So what I'm going to do is remember that what I'm thinking here, is that, thinking of your Pythagorean identity that says cotangent squared theta plus 1 equals cosecant squared theta. I'm kind of looking at all the trig terms here, and they have only those in common. So what I'm going to do is take this cotangent squared on top and change it to be, if I move the 1 over here, that'd be equal to cotangent squared. So change it to cosecant squared theta minus 1 over 1 plus cosecant theta. And then I'm going to factor this using difference of squares. So that's the same thing as cosecant theta plus 1 times cosecant theta minus 1. All over that 1 plus, which technically I could rewrite it as cosecant theta plus 1. You can just reverse the order. And then you should notice that this factor is the same as this factor, so those cancel. And I'm left with cosecant theta minus 1. Now remember, you're trying to get to 1 minus sine theta over sine theta. So I need to change cosecant to what it is in terms of sine. And cosecant is the same thing as 1 over sine. And I'm going to break that up into two things. I'm going to actually change that 1 to be sine over sine, because that's the same thing as 1. And that way I have a common denominator. So now when I combine my numerators, I get 1 minus sine theta over that common denominator, which is exactly what I want it to be. So we have verified it. Okay, on this next one, I'm probably going to work with the right-hand side. So we've got tangent to the fourth x equals, I'm going to factor out my greatest common factor, which is tangent squared x. And then I'm left with secant squared x minus 1. Remember your trig identity, or your Pythagorean identity. So I'm going to replace, I'm trying to get where I only have tangent to the fourth. So I'm going to replace this. If I move the 1 over, it's the same thing as tangent. So replace it with tangent squared. When you multiply tangent squared times tangent squared, you get tangent to the fourth x. And you're done. All right, over here, same difference. I'm going to work on the right-hand side. Let's see. Let me clear all this off. So on the right-hand side, I'm going to factor out cosine to the fourth out of both of those. So cosine to the fourth alpha, and then you're left with 1 minus cosine squared alpha times sine alpha. Now I'm trying to get sine cubed and cosine to the fourth. Well, I've got cosine to the fourth already. This is the same thing as sine squared. So we'll replace that. And when you multiply sine squared alpha times sine alpha, you get sine cubed alpha. So that'll be sine cubed alpha times cosine to the fourth alpha. And that's exactly what I want it to be. So it's verified. All right, on the last one, probably going to work on the right-hand side again. Similar situation. I'm going to factor out a cotangent to just cotangent. And we'll be left with 1 plus cotangent squared theta. So, whoops. One plus cotangent squared theta is the same thing as cosecant squared theta. And then these two will combine to be cosecant to the fourth theta times that cotangent theta. And we verified it. All right, that's all for these notes, guys. Thanks. Actually, I'm going to go a little bit further. I'm going to do some of these practice ones on the next page. I hope that doesn't confuse people. Anyway, on example 1, I'm going to distribute that secant through there. So when you do secant times secant, you get secant squared. And then when you multiply secant times cosine, those are reciprocals, and they will always multiply to be 1. And then secant squared minus 1 is the same thing as tangent squared. And so we have simplified that. On the next one, same thing, going to distribute. So I get 1 plus tangent squared x. Oops. And then that's the same thing as secant squared x. So I'm done. Remember, when your directions say to simplify, you're trying to get to one trig function if you can and no fractions. On the next one, I'm going to think of that as sine x over 1 over sine x plus cosine x over 1 over cosine x. And remember, when you do sine x divided by 1 over sine x, that's the same thing as saying sine x times sine x over 1, which is going to be sine squared x. Same situation over here. Well, you'll end up with cosine squared x. And then those two, because they're both squared, they add together to be 1. On the next one, I've got two terms here. The two terms have cosecant squared in common. So I'm going to pull that out as a GCF. And when I do, I'm left with 1 minus cosine squared x. Well, 1 minus cosine squared is the same thing as sine squared. And then cosecant squared and sine squared are reciprocals, and when they multiply together, they give you 1. All right, on number 5, this is a difference of squares, so when I multiply it out, it'll give me secant squared x minus 1, and then that's a Pythagorean identity, so that's the same thing as tangent squared x. On the next one, we have secant squared in common between these two terms. So I'll pull it out as the greatest common factor, and I'm left with 1 plus tangent squared x. Remember, when you pull that out as the greatest common factor, you're basically dividing each term by what you pulled out. So secant squared divided by secant squared is 1. Tangent squared secant squared divided by secant squared is tangent squared. And then remember, using your Pythagorean identity, that this is secant squared theta, or x. And when you multiply those together, you get secant to the 4th x. All right, on 7, about all we can do here is that's a difference of squares, and that'll factor to be cosine squared x minus sine squared x times cosine squared x plus sine squared x. Well, the one on the right is just 1, so you're just left with cosine squared x minus sine squared x. Sometimes you'll have verifying problems which make you go even further from there, but for our purposes, that's far enough. Okay, on the one on the right, all you can do here is just factor. And you know that 2 secant x times secant x will give me 2 secant squared x. You know you need a 3 and a 1. I'm going to put the 3 here and the... no, I'm not. I'm going to put the 3 here, so that this will give me 6, and I'll put the 1 here, and I'll need that 6 to be positive and the 1 to be negative, so they'll combine to be the positive 5 secant x. And that's all I can really do with that one. All right, on the next one, it wants me to verify, so I'm going to keep the right-hand side the same. I'm going to distribute sine, and when I multiply sine times cosecant, they're reciprocal, so that's 1 minus sine squared. And then 1 minus sine squared is cosine squared, so we're done. All right, on the next one, I need a common denominator, so I'm going to multiply the left hand by sine x over sine x, and I'm going to multiply the right by 1 minus cosine x over 1 minus cosine x. Okay, so on the left-hand side, you're left with sine squared x over that common denominator. And on the right-hand side, now remember, these are not a difference of squares. So you've got to think about how you're doing 1 minus cosine x times 1 minus cosine x. And you have to distribute all the way through there. And so it ends up being 1 minus 2 cosine x plus cosine squared x, all over that common denominator. Okay. So now that I have a common denominator, I can add the numerators. So I'm going to kind of reorder the top there to kind of show you. I'm going to move this one right next to that one. And then plus 1 minus 2 cosine x. All over that common denominator. This is the same thing as 1. And when you combine this one with this one, you get 2. So you'll have 2 minus 2 cosine x over sine x times 1 minus cosine x. Factor out the 2 on top. And then that cancels with that. You're left with 2 over sine x, which, I'm sorry I'm running out of room. It's the same thing as 2 cosecant x, which is what we're trying to get to. Okay, on the next one, I'm trying to make it equal 1. That'd be the easiest. So on the left, I have a GCF of cosine squared. And then 1 plus tangent squared is the same thing as secant squared using my Pythagorean identity. And then those are reciprocals, so that's 1 equal to 1. On these, this is a difference of squares. It'll multiply out to be 1 minus sine squared x, which is the same thing as cosine squared x. So I have verified it. On the next one, let's see. I'm going to pull out my cotangent squared x. And then this is the same thing as cotangent squared x. So when I multiply those, I get cotangent to the 4th x, and I've verified it. On the next one, you need a common denominator because you have 2 fractions that are being subtracted. So I'll multiply this one by cosine over cosine, and I'll multiply this one by sine over sine. Each of those. Okay, so you end up with, when I multiply cosine times secant, I get 1 over that common denominator. And then on the other one, I get sine squared over that common denominator. So on top, when I combine those the numerators, I end up with 1 minus sine squared, which is the same thing as cosine squared. And then this cosine x is going to go into that one and make it just plain old cosine x on top. So you get cosine x over sine x, which is the same thing as cotangent x, and that's what we're trying to get to. Okay, on the next one, let's see. I guess I'm going to work on the right. So I'm going to distribute this. Well, no, I'm not. I'm sorry. I'm going to notice that this right here is a Pythagorean identity. So I'm going to change it to be cotangent squared x. Cotangent squared x in terms of sine and cosine is the same thing as cosine squared x over sine squared x. Multiply straight across and you get cosine cubed x. And then, that's the same thing as, well, I'll write it. That's like saying cosine squared, oh goodness, cosine cubed x divided by sine squared x, which is the same thing as cosine cubed x times 1 over sine squared x. And 1 over sine squared x is the same thing as cosecant x, cosecant squared x in this case. Oh wait, hold on, sorry about that. I wasn't paying attention to what I'm trying to get to. I'm trying to get to cotangent cubed over cosecant. I don't know what I was thinking, sorry. So what I want you to think about, I'm going to back up a little bit. I'm going to erase all this down here. What I need is for I need a cotangent and a cosecant. Well, I know cotangent is the same thing as cosine over sine. So right now I've got, I need more sines on the bottom to make it sine cubed. So I'm going to multiply the top and the bottom by sine. That way I'm multiplying it by 1 and I'm not changing anything. And that'll, if I multiply this with this, I get cosine cubed x over sine cubed x. And I still have that sine x over on top over here that I'm multiplying by. So then that gives me cotangent cubed x. And then I can say that's the same thing as times 1 over cosecant. because cosecant is a reciprocal of sine. And so you end up with cotangent cubed x when you multiply straight across over cosecant x. Sorry about that. I made that completely messy because I wasn't paying attention to what I was trying to get to. All right, on the next one, I'm going to work, let's see. Sorry, I just had to erase that to give myself some room. Okay, I'm going to work this side and make it look like this side. So I'm going to change it using my reciprocal identities. Get a common denominator, so multiply this one by sine squared on x on top and bottom. Multiply this one by cosine squared x on the top and bottom. And that gives me sine squared x plus cosine squared x all over that common denominator. Oops. Okay, then on top, that's the same thing as 1. And then that will simplify to be cosecant squared x, secant squared x. And I can switch the order around to match that one. And we're done. All right, y'all. Now I'm really done with these notes. Thanks.